This is 1-1, variables and expressions. Expressions do not have an equal sign. These are some keywords to help us translate between expressions and verbal phrases. The ones people tend to have trouble on is that quotient goes with division and product is multiplication. Example 1, we could pick multiple things, so I'm just giving an example here. Example 1a, 3x squared. That could be the product of 3 and a variable x squared. 5z plus 16, that could be 16 added to the product of 5 and a variable z. And then the next one, it could be 1/2 multiplied by a, then added to the quotient of 6 times b and 7. Okay, example 2. These phrases more than, less than, greater than, I usually reverse the terms on those. It wouldn't matter for adding, but it would matter for subtracting. So just by habit, I actually reverse the term. So a number t more than 6, I would put 6 first, and then more than is plus, and then the t. 10 less than, so remember I'm going to switch these. 10 less than the product of 7 and f. Well, the product of 7f is 7f. And then the less than was our minus, and then the 10. Those are just for the more than and less than phrases. But now 2/3 of the volume, well, of is multiply, so this would be like 2/3 times the volume v, which we can just write as 2/3 v. Now for evaluating each expression, every time we replace a variable, please do so with parentheses out of habit. It especially matters for multiplication and when we have negatives. So like here it won't matter as much because it's addition, but it doesn't hurt to have it. So x plus y is 6 plus 9, which is 15. Notice I did not have an equal sign anywhere in my problem because this started as an expression. So I shouldn't be writing that it equals 15, just simplifying it to 15. Now x over z, that would be 6 over z, which is 2. Well, 6 over 2 becomes 3. No equal sign again. Okay, Mr. Martinez orders 250 keychains printed with his team's logo and 500 pencils printed with their web address. Write an algebraic expression that represents the cost of the order. So if he gets 250 keychains, let's call that K, and 500 pencils, let's call that P, then that's our algebraic expression that would represent the total cost. Now, some people are going to be tempted to write equals T or equals C for total cost. You cannot have an equal sign because it's an expression. No equal sign. Okay, now these are basic equations. This should really be review for you guys. Solving equations by addition and subtraction. Let's take a look at the first example. So example 1, let's look at 1a first. Here's my variable c. I usually like to block that off so I can see what's happening next. I need to get rid of that minus 22. So I'm going to add 22 to both sides. Now you may be able to solve these in your head or figure out what number, subtract 22 from that, would get me 54. Don't do that. You will not be able to do the advanced equations in this class if that's how you're doing it. That's great mental math, and that's great to check your work, but it doesn't work for this situation. Now to check your work, you would plug that back into C, so it would be 76 minus 22 equals 54. This is the original equation. Instead of C, I wrote 76, and I'm going to calculate that. Well, 76 minus 22, that's 54 equals 54, so that's correct. Next one, here's my variable j. Block that off. I have minus 87. The inverse operation of that would be to add 87 to both sides. So J equals, and that's going to be positive 84. I'll show you how to use your calculator with negatives if you want to learn that. Remind me, we'll do that in class. So J equals 84, and then we're going to plug that in. So J is 84 minus 87, and we need to see if that equals negative 3. Well, negative 3 equals negative 3, so that's correct. Okay, next one, we have 2/3 equals r minus 1/3. Well, here's r. It's on the other side. It's on the right side this time, but it doesn't matter. I need to get rid of this minus 1/3. So we're going to add 1/3. Again, you can do this on your calculator. I would hope that you can do this in your head at this point, but if not, you can use your calculator. We have common denominators, though, so 2/3 plus 1/3 is 3/3, but 3/3 is equivalent to 1 whole. So r equals 1. So if we check that, we would plug it back in. So 2/3 equals r is 1 minus 1/3. So 1 minus 1/3 is 2/3. So 2/3 equals 2/3, and we're correct. Now these are going to be subtraction property of equality. So when I look at these, I have my m is right here, and it's 63 is being added to that. So to get rid of 63, I would have to subtract 63 to clear it from that side. So I subtract 63 from both sides, and I get m equals 16. Plug that in to check. 63 plus m, which is 16, is equal to 79. 79 does equal 79, so that's good news. Okay, next, here's my variable p on the right. I need to get rid of the plus 16. So I'm going to subtract 16 from both sides. So I end up with, those are same signs. They're both negative, so I actually add them and keep the sign. So that's negative 28. Again, your calculator can take care of those negatives for you. So now I'm going to check my work on this negative 28. So negative 12 equals p, which is negative 28 plus 16. Negative 12 equals, those are different signs, so I subtract them to get 12, keep the sign of the bigger number, so negative 12 equals negative 12, so that's correct. And here we have decimals, no big deal, it follows the same process. There's my variable x. I need to get rid of plus 0.2, so I subtract 0.2. Just like fractions, you need common things, so I'm lining up my decimal point here so that we have our place values common, so that we can actually add or subtract them. So 0.9 minus 0.2 is 0.7 equals x, so that's my answer. Let's plug that back in and make sure 0.9 equals 0.7 plus 0.2. Well, that's true. 0.9 equals 0.9. So we are good there. And now translating equations. So the difference is that we're going to have the word is somewhere because that's an equal sign. So let's look and see. Example 3a, 7 times a number squared. So 7 times a number, we'll call it n, squared, is, so equals 5 times the difference of k and m. There's a couple of different ways you could actually end up writing this. 5 times the difference of k and m. Difference of is subtraction. That's what I would think most people would have, but you can, I don't really want to say argue, but we can have a discussion about that because some people might put something a little different, and that may actually be okay. 15 times a number subtracted from 80 is 25. So 15 times a number subtracted from, when we subtract from something, we're taking it away from 80, is equals 25. So notice those have equal signs where our expressions did not.